This is a model of boron trifluoride. As what you can see, all atoms on the same plane, right, and has a trigonal shape. So trigonal planar. Alright, so now I'm going to find out the symmetry elements operation for this molecule. So the first symmetry element is rotation axis. So this axis passing through the central atom, which is the boron. Alright, because this molecule has trigonal shape, so it should be the angle between fluorine, boron and fluorine is 120 degree. So same here, 120 degree, and this one. Okay, so it means that if you want to rotate this molecule passing through this axis, so this axis is C3 axis because we want to rotate 120 degree. So from here, stop, and we get the same configuration. And from this axis, we can also rotate 360 degree. And we get the same configuration. So now we want to label where is the position for the C3 axis, because the C3 passing through the central atom, boron, so we just draw a point. It means that passing through from the top to the boron central atom, and label as C1 and C3 axis. I find out this molecule have another rotation axis, which is C2 axis. So the axis passing through the BF bond here. Alright, so we can rotate 180 degree. So just imagine like this. Okay, the axis passing through the BF bond, and then we rotate 180 degree. We get the same configuration before and after. Because this molecule has 3 BF bonds, so it means that the C2 axis can be here, can be here, and can be here. Alright, so it means that 3 C2 axis for this molecule. So we can label like this. Alright, the next symmetry element is reflection, which is we need to find out the internal plane. So because this is planar molecule, so it means that it can have a plane that cutting through all atoms. So we just imagine that this plane cutting through all fluorine and boron. So cutting through all atoms, the whole molecule. Alright, so let's say, just imagine that the plane is like a mirror. So the mirror cutting through all atoms, the mirror plane. So reflection, we will get the same configuration before and after. Okay, so this plane actually perpendicular with the main axis, C3 axis. Okay, so that's why this plane is known as horizontal plane. So we draw like this and label as sigma H, horizontal plane. Okay, so this molecule also can have another plane, which is the plane that cutting through bond, BF bond. So you just imagine like this, the plane cutting through the BF bond. So, and also cutting through the angle 120 degree here. So this kind of plane actually is parallel with the main axis, so it's known as vertical plane. Alright, so look, we get the same configuration before and after. So actually the plane also can be here and also can be here. So there are 3 vertical planes for this molecule. So we can draw like this. Sigma V alright. So next we want to find out improper rotation, which is Sn. So this molecule has C3, so we want to find out S3. So this is the C3 axis. So we rotate 120 C3 axis, and after that reflect. So the plane should be perpendicular with the axis, C3 axis. So when reflect through this plane, so we will get the same configuration before and after. So it means that this molecule has S3 symmetry elements operation. Okay, alright. So next we want to find out this molecule has C2. So how about S2? So actually S2 is equivalent with center of symmetry. So let's find the center of symmetry for this molecule. So the center should be in the middle. So we just imagine that the center should be here, boron. So if we just imagine that we put the center here, and then we want to inverse all atoms. For example, this fluorine, inverse through this center, so this fluorine will be there. So we don't get the same configuration as before. So this one also, fluorine inverse through this center, so this fluorine will be here. So again, we don't get the same configuration as before. So that's why this molecule doesn't have center of symmetry. So no center of symmetry, it means that no S2. Alright. So now we want to list all the symmetry elements operation for this molecule. So this molecule of course has identity and S3, yes, C1, C3 and 3 C2, sigma H and 3 sigma V, vertical planes. Alright, so that's all the symmetry elements operation for this BF3 molecule.